This morning I was going through Reddit and I was checking the SolidWorks subreddit, came across this post asking for advice on how to draw this part. And at first it is a very simple part to draw, but there are a couple of little tricks that I think you should be aware of when drawing it. At least there is a very effective way of drawing this. It's designed to make you think a little further. So I thought I would do a video and show you how I personally would draw this and show you a few tips along the way to really maximize your efficiency in SolidWorks when drawing something like this. So let's get right into it and I'll show you how I would go about drawing this particular part. Okay, so let's get started. The first thing is there's a lot of people saying you should start with the hexagon first. There's other half saying you should start with the C shape first. The way I see it is originally I thought you should start with the C shape and then do the hexagon, but because of the way it is dimensioned, I think for the purpose of design intent, you should actually start with the hexagon. The reason why is whenever you're thinking about design intent, you want to try and do things in as little steps as possible. That's one of the things about design intent, trying to keep things as simple as possible. And because of the way this is dimensioned, if I was to do the C shape first, I would have to try and figure out this dimension because as you can see, the hexagon is 22 mils high, and then the top of this face is 7 mils down from the top of the hexagon. So if I was to do the C shape first, I would have to think, all right, so you got 60, but that's below the 22, so 22 minus 7. So it's just a lot more thought process. But if I was to draw the hexagon first, then when I draw the C clamp, I can just simply dimension this 7 down to get that height. And then I have 60 down for the rest of the height. So it just makes things a little simpler. I don't have to think about maths. And if there was any changes in the future, which again is design intent, thinking about what could happen in the future if you need to modify anything, it is likely that maybe the engineer needs this to be 10 mils from the top of the hexagon. So you could simply go into the sketch and change that to 10, done. You don't have to do any calculations in your head. So it just simplifies things this way. So that's how I would do it. Let's go into SolidWorks. We'll start a part, and I have this drawing up, but just to save space, I will keep this off the monitor when it's not needed. When I do need to show something, I'll just bring it back on screen here and explain something. So the first thing we need to do is draw the hexagon. The hexagon is best drawn from this point here should be your origin point. I think everything should be based around that. And again, design intent, you need to think about where you're beginning your drawings and basing everything around that. So when you do make modifications or adjustments in future revisions, it kind of bases itself around that origin. That's where I would start. That's where my origin point would be. We got a hexagon that's 22 high. It's 19 AF. The AF stands for across faces or across flat. And it just means that the dimension is taken from that flat to that flat. And these are all in millimeters in case anyone's wondering. Back into SolidWorks. So we're going to draw that hexagon from the top plane. So we'll start a sketch on the top plane. Here is my origin point. We can use the polygon tool to create this. We'll have our side set to 6. Everything else is fine, not construction, that's fine. And we're just going to pull this out. Just be aware of the original drawing had the furthest point sort of on that center plane. It's not like this, it comes out like this. So we're just going to pull that out, and then we can go and dimension one of these sides. So we can just any two opposite faces is fine, and that was 19 cross faces or across flats. If I bring this back, there's actually a circle hole punched through the center of this hexagon. It's 10 mils. Instead of doing that, it will be done as a separate feature, but instead of creating a new sketch on the top of this surface, I'm going to do it all part of the one sketch and then reuse the same sketch later on. What I'll do is I'll drop a circle here, and that was 10 mil. And that's just in the center. So that is the hexagon part done. Control 7 to go into isometric, and I want to extrude that. The contours though, I actually want this center point and this point. So I want the whole thing. It was 22 mils high and done. So that's the first part. The next part is drawing this C-shaped clamp. And this is where you can do something a little more efficient with your sketching. Some people would probably say draw or sketch one side of it because it is a symmetric shape, so you should be using the mirror tool. So you would sketch one side, extrude it, and then mirror to the other side. But that's 3 steps. You can actually do that in 2 steps. You could sketch this side, mirror the sketch to the other side, and then extrude it. So that's, 2 features, a sketch and an extrude. But you could make that even more efficient, and I'll show you how. What we want to do is we're going to do a sketch on the front plane, and we're going to use a tool called dynamic mirroring. What this does is it's mirroring everything we draw on one side to the opposite side at the same time. To start this command, first we need a center line. And that center line is just going to be from the origin point up. What we do is we go to Tools and then Sketch Tools, Dynamic Mirror. If you don't have the center line selected, it will ask to select a point or a line, and you'll pick that. But you can tell the Dynamic Mirror is now activated because of the equal signs. So the magic here is that if I start to draw, and we're just going to draw the profile, so we go out and we go down and we have this little bit and this little bit, and we go across and then up and across, and that's it. So you can see how cool is that? It's, as I've drawn this side, it's actually drawn it on the opposite side. There are a couple of holes in here, but I will do that as a separate feature. We'll actually use the hole wizard to do that. But for the moment, that's just saved us so much time just by doing that. And we no longer need the dynamic mirroring activated, so we can just go to Tools, etc. Or there is another way. If you right click, you can go to Recent Commands, Dynamic Mirror, and this is now turned off. So if I draw another line for whatever reason, it doesn't draw on the other side. Actually, it is drawing on the other side because I had this line activated. So let's just go back. Okay, it's turned off now. We don't have to worry about it. But generally, you turn it off, and if you draw, I'll quickly explain. But now that dynamic mirror is off, if we draw a line here, you'll see that it doesn't mirror to the other side. Next, we just need to do these dimensions. And when you're dimensioning from a reference like this, I find it is good to actually kind of copy the dimensions the way they've done it. That way, if you ever need to adjust anything, generally everything's in the same space. You don't have to go hunting for like, oh, did I put this 60 on the other side? Or it just makes things clean and clear. So try and do your dimensions based off the same way they've done it. And the cool thing is that because we've done the dynamic mirroring, everything is symmetric as well. So we can easily do these same dimensions. So we're just going to start from the outside so it doesn't sort of mess things up, but we'll go, this one is 130. The other thing with dynamic mirroring is everything is symmetric now. It's symmetric relations are already applied. So as I move this in, it will move on the other side automatically. We need a few more dimensions, so we're going to go through these. The next one is 110, and then you've got this one, which is 90, this one, which is 8. Okay, and this is why I wanted to do the C shape as the second feature, because now I just need to I just follow the same dimensions it has on the original reference, which has a 7mm from the top of this to this shape. And that way I don't have to think about having to calculate things, going up 22, coming down 7, basing that off the 60. It's just easier this way. So that's why I'll do this feature second. The last dimension we need is the 60 on the side. That makes our sketch fully defined, and that completes the sketch. You could also add the chamfers in here as well, but I'm going to do that as a separate feature. It would simplify things by making these chamfers in and then creating the feature, because that's only 2 steps. I find it's just easier to modify either fillets or chamfers as their own feature rather than having to go back into the sketch and trying to modify them that way. So we can now extrude this, and the thickness is 8 mils. So we can go extrude. It's going to ask for our profile. So we pick this. Make sure you can right click and go to mid plane, and then the thickness is 8. Right click, go OK. So that's completed the profile shape of the C. A few more things to do actually. So the next thing would be this center hole through the middle. So we will reuse the original sketch of that hexagon. So we are going to go back to Extrude Cut, go to the original one and we'll pick this. And then for our contours, we're going to clear selections and try and pick this center circle. Okay, we're going to flip, or we can just say through all. Yeah, that's fine. Actually, that's direction 2. Sorry, it doesn't really matter, but let's just try and keep it clean. So we just go through all both directions. That's fine. And therefore we now have our cut. The reason why I didn't do this in one piece is I did it in an earlier trial, and this was then had solid mass through the middle of the hole. Another way I could have done this is if we just roll back, I could do another sketch on top and then cut a hole through, but that's adding another sketch and then another feature. I find it's easier just to try and do as much as you can in one sketch and just sort of pull features out from that as you need it. Let's go on to the chamfer. And if you look at this, the chamfer is 7 times 45. So this is using a distance angle chamfer. So the distance is 7 and the angle is 45. There is a angle distance type of chamfer in SolidWorks, so we're going to use that. Is set to 7, or we can set it to 7 and 45, and we just pick those 4 corners that we want the chamfer applied to. And done. Okay, so we're almost finished now. The next thing is these holes. Now I'm going to use the hole wizard to do this. You could just do a sketch in a circle and cut them through, but I want to use the hole because if this was an actual job you're working on, you'd probably have to do a technical drawing afterwards. And so by using the hole tool, it just makes any notation easier. Let's just have a quick look at this too. You can see it's 70 to across from center to center, and it's pretty much, it's still symmetric, and it's 7 down from the top face. So the way I would do this is by going into features, and then we're looking for hole wizard. We'll just pick a hole. So in here, it is a size, we're going to make it is a 10. If there's any other options or anything like near side countersunk or anything, you can just untick that. And then we go to our position. We'll ask to select a face. So we can pick this face, and it's going to ask where to drop it. But first I'm going to use the dynamic mirroring again. I'm going to create a center line, go to tools, sketch tools, dynamic mirror, and then I'm going to drop my point here. And that way it automatically dynamically mirrors it to the other side. Right click, go to recent commands, dynamic mirror, and then we just need to add our dimensions. So this is 7, I think, 7 from the top, and then it is 70 across. Yes, 70 across. We go okay, and we are done. So that's how I would do it. And this has created, let's have a look, 1, 2, 3, 4, 5 features. I think you could make that maybe one less feature by, putting the chamfers into the sketch itself, but I like to do chamfers or fillets as a separate feature. I just find it's a little easier to modify them. If I needed to modify this, I could just go to edit feature and change it to 10 or something like that. So it just makes modification a little easier. I could also rename this to, corner chamfers or something like that, and it just makes it a little more obvious rather than going which sketch was it this one? Oh yeah, it's that one. Going into it, adjusting it this way. So that's why I like to do chamfers and fillets as an individual feature, just for that design intent and the simplicity of changing it later on. So that's how I would do this particular model, and thank you to the original user for posting it. If you would like to see other little issues like this, or if you're having difficulties drawing a particular part in SolidWorks, something basic like this, and you'd like me to do a commentary of it and see how I would personally do it, just tag me in the post and I'll take a look. If you liked it, please like the video, please subscribe to the channel. I'm growing slowly but steadily, and if you haven't seen it already, I'm also doing a complete course on the CSWA course, the SolidWorks Certified SolidWorks Associate course. Just going through chapter 1 at the moment. That's almost finished. Should have that completed soon. So yeah, that's all for this video. I just wanted to show you how I would have personally done this particular model. It's a fun little challenge and a few little things that I think most people didn't really think about on why you would actually draw it this way. No way is the perfect way. There's probably someone else who has a better way or a different opinion on how you should draw this, but personally that's my opinion on how you should draw it. And I really like the subtleties of the most efficient way of drawing this model would have been. And I hope it helps the original person who was having issues with this one on how you'd look at drawing this from a more professional sort of way. Until the next video, catch you then.